This lecture is going to be about k-means clustering. And k-means is actually a relatively old technique that was developed quite a while ago, but it remains very useful for kind of summarizing high-dimensional data and for getting a sense of, what patterns your data show and what observations are similar to each other and what observations are very different from each other. So we're going to talk a little bit about how k-means works and show what it can do for you. So the basic principle behind k-means clustering is that you have to first define what does it mean for things to be similar to each other, and what does it mean for things to be different from each other. So in some sense, you want to define, what does it mean to be close, how do we group things together, and how do we visualize this grouping. And then once we visualize the grouping, how do we interpret what we see. So I think the most important thing is to define, what do we mean by close. So we need a distance metric to define what it means for two things to be close together, because depending on the context, two things could seem close but not be very close. And then in a different context, you could have a totally different meaning of distance. And so this is a very important step, and if you don't do it well, you end up with nonsense at the end. So you get kind of the classic garbage in, garbage out. So the couple of traditional distance metrics in statistics are having a notion of continuous distance, which is like a Euclidean distance. So this is like the straight line between 2 points. Another continuous measure is basically like a correlation similarity between, let's say, two variables. And so you can see how correlated they are or how similar they are. So highly correlated points would be very similar. And then another distance is called the Manhattan distance. And this is we'll talk a little bit more about this a little bit later on. So you need to pick a distance or similarity metric that makes sense for your problem. So k-means clustering is a way of partitioning a group of observations into a fixed number of clusters. And so the idea is that you have to say beforehand how many clusters of points are there. So for example, if you have 100 observations in your data set, you might think that they could be neatly divided into, say, 4 different groups. Okay, so you have to have a sense of how many clusters there are first. And then each of these groups is going to have a centroid, right? So it's going to be like a center of gravity around which each group kind of gathers. And then once you have these centroids, we kind of assign each of the observations to each of these centroids, and that's how we do the group kind of assignment. And so the basic approach is to kind of pick the algorithm for running k-means is to kind of pick a centroid, assign all the points to the centroids, and then maybe recalculate the centroids and reassign all the points. You kind of iterate back and forth until you reach a solution. And so the things that you need a distance metric. You need a number of clusters, so a fixed number of clusters that you have to specify beforehand. And you need an initial guess as to where the centroids are. And often you might just pick some random points just to start the algorithm in terms of where the centroids are. The k-means clustering algorithm will produce a final kind of estimate of where the cluster centroids are. And it will tell you which centroid each observation is assigned to. So here's a quick example of how you might use the k-means clustering algorithm. And I've generated just some random data here that are in 2 dimensions, so it's easy to visualize. And so the x-coordinates and the y-coordinates all come from a normal distribution with different means. So I've specifically created 3 different kind of clusters for these 12 observations. So each cluster has 4 observations in it. So when I plot the data, it's very obvious that this is where that there are 3 clusters. I put labels on each of the points. So here we see that the algorithm started, and I've just chosen some 3 random points to be the centroid. So you see there's a kind of a red plus and a purple plus and an orange plus down at the bottom. So those are the random starting points for the centroids. And then you can see the first thing we're going to do is we're going to take each of our data points and assign to it the closest centroid, right? So you can see, for example, point number 8 at the very top. The closest centroid is the red plus over on the upper left, so that gets assigned to that cluster. And then point number 4 down in the lower left here, that gets assigned to the red cluster also. And then the 3 points 1, 2, and 3, they get assigned to the orange plus. They're in the orange cluster. And then the rest of the points are closest to the purple little plus there, so they get assigned to the purple cluster. And so that's the first kind of initial grouping of the points to the 3 different clusters. And then the next thing we're going to do is we're going to recalculate the centroid. So now we have the cluster definition. Every point is assigned to a cluster. We can recalculate the centroid. So, for example, by taking the mean of that cluster. So now you can see that the purple plus has been moved slightly to be in the middle of that cluster. The red plus has moved a little bit to be in the middle of that cluster, and the orange one is now in the middle of the 3 orange dots. And so the cluster centroids get recalculated. And then you kind of repeat the process again. So you take each data point and you say, okay, well, what cluster centroid is it closest to now? And you can see that point number 4, for example, used to be in the red cluster, but now it's closer to the orange cluster, so it gets reassigned. And then you see, for example, point number 7 is now closer to the red plus, so it's in the red cluster. And then when you recalculate the centroids from this, you see now the centroids are kind of moving towards each of the points. So you can see how the clusters are kind of forming as we go step by step. So the 2 processes are to assign the points to each cluster, and then to update the centroid locations.